All right, good. All right, guys. So today we're gonna start chapter 7. Now, chapter 7 is on sequence, as you can see. So let's just go to the next page. So here's how we start out. I start out by saying that a sequence is a function whose domain is the set of all positive integers. A sequence is a function whose domain is a set of all positive integers, while a series is a list of numbers added together. A sequence can be written as a list of terms. It can be a formula or function, or it can be a recurrence relation. Notation, if UN is a sequence, it's denoted UN or UN, that's U subscript N. Now in the sequence U subscript N is the term number. So U1 would be, U subscript 1 would be term 1, U subscript 2 would be term 2, U subscript 3 would be term 3, etc. You can graph a sequence since a sequence represents a function. So since a sequence is a function, you can graph a sequence where the term number n would be your domain. Now, a finite sequence contains only a finite number of terms, whereas an infinite sequence is unending. Types of sequence. So we're just going through some, let us say, preliminary information before we get into the real meat of the matter. So types of sequence, the different types of sequence, the different types of sequence can be described as convergent, divergent, oscillating, periodic, or alternating. Here it is. A sequence is convergent if the values approach a fixed point as n increases. That is, as the limit of un as n approaches infinity, if the limit of un as n approaches infinity is a value, we say that that series that sequence is a convergent sequence. Divergent sequence, any sequence which does not converge is called a divergent sequence. A sequence which diverges can, 1, diverge to positive infinity, or 2, diverge to negative infinity. Still under types of sequence, we have oscillating sequence. Oscillating sequences are neither convergent or divergent. For example, the sequence -1, 2, -3, 4, -5 is an oscillating sequence, as is the sequence 1, 0, 3, 0, 5, 0, 7, etc. These are oscillating sequences, can be divided into 2 types. An oscillating finite sequence, which is bound but not convergent, and an oscillating infinite sequence, which is neither bound nor diverges. So the diagram on the left, that's your what? Bound and oscillating. The diagram on the right is your what? Oscillating sequence, which is neither bound nor diverges to positive infinity nor negative infinity. So all these are things that you can look at to see if you can see meaning in it. But it's not information that you can ignore. You need to read it. read it and consider it. So let's talk about periodic sequence. A periodic sequence is a sequence which repeats its term regularly. The smallest interval with which the sequence repeats itself is the period of the sequence. So the sequence 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and that continues on forever, is a periodic sequence, and its period is 3. So this sequence repeats itself every what? 3 what? Terms. Alternating sequence. An alternating sequence is a sequence with terms that alternate between positive and negative values. Alternating sequences can be convergent or divergent or oscillating. For example, -1, 0, 3, minus 0.30, 0.3, minus 0.003, etc. is an alternating convergent sequence. And the sequence -1, -1, -1, -1, -1, it's alternating and it's what? Oscillating. Terms of a sequence. Now, a sequence 1, a half, 1/3, 1/4, 1/5 can be written as UN is equal to 1 over N. This represents a rule for the nth term of a sequence or the general term of the sequence. The list of terms can be replaced by the formula for the nth term. The list of terms can be replaced by the formula for the nth term. What I think